Hello, and welcome to the CCNA Routing and Switching course offered by SimplyLearn. The previous lesson focused on DHCP, NTP, and high availability. This lesson will deal with Enhanced Interior Gateway Routing Protocol, EIGRP. Let us begin with the objectives of this lesson. By the end of this lesson, you will be able to describe EIGRP's metrics and administrative distance, describe how EIGRP's topology and routing table are created, including dual, describe automatic and manual summarization, describe neighbor requirements, configure EIGRP for IPv6. Let us discuss EIGRP in the next slide. Enhanced Interior Gateway Routing Protocol, EIGRP, is a proprietary Cisco protocol. It replaced Interior Gateway Routing Protocol, IGRP. EIGRP is an advanced distance vector routing protocol, but it is also called a hybrid. It does not have a total view of the network as a link state protocol would. EIGRP does not require a hierarchical addressing scheme, but it works better with it. EIGRP is the only routing protocol covered in this course that can support non-IP protocols. Protocol-dependent modules, PDMs, handle Novell IPX, AppleTalk, as well as IP. Convergence occurs rapidly. A network needs to converge or settle down to normal operations after a change. For example, if a router interface fails, many events occur. The router recognizes that there is a failure. The neighbor or neighbors on the other side of the link recognize that there is a failure. The router and its neighbor must recalculate the routes for their routing tables since any routes using the interface no longer work. These are just a few of the processes that occur after a change in topology. The time taken for the completion of these processes is called convergence time. Let us discuss tables in the next slide. EIGRP maintains information in three different tables. The first is the neighbor table. To exchange routing updates, routers must become neighbors. EIGRP maintains information about these neighbors in the neighbor table. The second table is the topology database. A router stores the routing information it receives from its neighbors in the topology database. The dual algorithm is run against this topology database to determine the best route for each destination, which is offered to the IP routing table. The third table is the routing table. This is the IP routing table, shown with the show IP route command. Now we will discuss how routers become neighbors in the next slide.